Anything else? So, I do have to apologize. I graded some more homework, and there were people that were obviously just copying out of, and it just kind of pisses me off when that happens, especially when I make a big deal out of it. So stop, right? If you keep doing it, I'm just going to say, don't give me any more homework. You got a 0 homework grade. Just stop. Okay? It's just wasting my time. I don't want to grade the answer key. Right? I already did. I already picked up the typos in the book, so now come on. Okay. So anything else with homework? You guys are good with homework? So let's catch up with where we were yesterday, where we left off. Okay. So the example we did yesterday was the probability of left-handed was 11%, so that was P, that was a success. They made 89% for the failure. I had 5 people, and I wanted to know the probability that exactly one of them was left-handed. So we made the list of all the different ways that they could be left-handed, and we did some algebra and noticed what the other part of the list was going to look like. So this is from yesterday. We did P was 0.11, Q was 0.89 for left-handed and not left-handed. N was 5. There were 5 total people. And the successes I wanted was 1. I wanted 1 left-handed. Okay, so I just generalized that up here, and there's the specifics from what we did yesterday. So just to cut to the chase a little bit, you could have the first guy left-handed while the other 4 aren't, or the second, or the third, or the fourth, or the fifth, so that the list ends up being 5 long. Right? And mathematically, each one of these looks like P times Q to the 4th. So it'd be this plus this. So you get 5 of these. 5PQ4. Now breaking this down, why does this make total sense? This is how long the list is. Because I'm going to add them all up, so this is just that. This is going to be how long the list is. The calculator is going to do that part for us. We're going to have the calculator count that list. You don't want to make that list if it's 7.2 million things long. Don't really feel like that. P to the first power, what does that relate to? P means success, and I want 1 success. So how many failures does that leave? 4. That's awesome if you let it be. So here's the general formula, and we'll talk about how to do this in that first piece in the calculator. So if I have a situation like this, the general formula, there you are. Binomial probability formula. With all those things, right? You got success, failure, you got N trials. So it's N dudes there. It could be rolling a die 12 times. It could be flipping a coin 30 times. So whatever you're doing repetitively, right? Each person, each roll, each flip, each whatever. This is the piece we're going to talk about right now that you do in the calculator. This is the symbol used. And let me break this down for you.
Oh.
A way to say this is I've got 5 people, and how many of those people do you want to choose to do something? I want how many successes in this problem? 1. So I got 5 people, and I want to choose one of them at a time to be the left-handed person, right? So this would be 5, choose 1, and if I do that in the calculator, it'll be how many ways there would be to do that. So if I do 5C1 in the calculator, it better come out to be 5. Because we already figured it out. There's 5 ways to do that. If I do 5C2, it'll be how long the list would be if I chose 2 to be P. And you see how that would suck to try to write that list out because it'd be so easy to miss one? Maybe it's the first 2 or these 2, or maybe it's this one and this one, and maybe it's this one and that one, and maybe it's the last 2. Oh my God. So thank God we're going to do that in the calculator. But what is this going to look like? How many successes do I want? X of them. That's what X means. So how many failures do I want? This is what we did yesterday. The rest, n minus X. The total minus the part I've taken already. And just visually, if I have n total things, right? And I choose X of them to be successes, how many, if I take that away, isn't that n minus X? I mean, that's, okay. All right, I like it. So let's talk about how to do this piece in the calculator. And actually, let's first take a different situation. Oh yeah, Jeff, you have to. There we go. Oops, let's not do that.
Oh, I was about to look at my grade. I was trying to find my name.
So in my calculator, it says NCR instead of the same thing.
I know, it's the same thing. Calculator just wants to use R. Can somebody shut that one that says whiteboard off? So let's make a situation, create the formula, and then we'll try to plug it in the calculator. Okay. So let's say we have, we know 23% of students have to take statistics, let's say. If we choose 38 students randomly, what's the probability that exactly, what you got, Jeff? Exactly 9 of them have to take statistics. So I want you to see how this formula is beautiful. It just sets itself up. Of course, you're going to have it on your formula sheet too and whatever. So first thing you want to do for yourself is identify all the parts. What's N? What's P? What's Q? What's X? Well, what's N?
38.
38. Always the total number of things, right? What's P?
23%.
Yeah, it's the probability of success, and I'm looking for people that have to take stats, so it's 0.23. So what's Q got to be?
1 minus 23.
1 minus 23.
So it's 0.77. And then what's X in this case? 9. I love it. So really you just got to plug and chug, but here's how to say it to yourself in English as you do it. How many people we got total? How many people we got total? 38. And now I want to choose how many of them to do something. 9 of them, right? I got 38 people. 38 people. Choose 9 of them to do something. So how many successes do I want? 9. So how many failures does that mean?
38 minus 9. 38 minus 9.
Yes.
29.
You got 9 already. 38 total people.
29.
There's number 29. Everybody keeps giving me a problem to work out. I already know my math. I want you guys to give me the number. All right, so here's how. Yes, ma'am. So two levels to this. I'm trying to get you guys to realize that you can read this as a sentence. I got 38 people. Choose 9 of them to be a success. So I want 9 of these, and that leaves 29 of these. On the other level, look how it's just. Is everybody cool with picking these out? And then you just throw them in. Right? I mean, if you know these, what do you do with them? You plug them in. Plug and chug. Okay, cool. So let's see how the hell to put this in the calculator correctly. I do have a worksheet for this. Okay, so if you have your calculator, play along. So first you put in there 38. That little intriguing math button. Hit math. And look at all this shit. I think I showed you this one, didn't I? The change it to a fraction. Yeah. Now let's go, then we've got number, you can take an absolute value of something, you can round something, the imaginary part of something. Ooh. Then you got this weird ass shit. This is basically all related to complex numbers, that's why it's CPX, complex. And then we got the one we want, the stuff related to probability. So I don't want National Public Radio, I want choose. I want number 3. The calculator uses R. Oh well, we'll get over it. We know it's X. So 38, choose. Now if you have the newer calculator, it went down, right? It went to a subscript. Whenever you're subscript or a superscript, you better hit the over button so you get the hell out of there once you plug the number in. Or you should be used to that if you're using the newer calculators. 38, choose what? 9. Times. What comes next? 0.23 to the 9. Times 0.77 to the 29. Let's make sure we all get the same thing. If you have an issue, let me know. If you can't figure out what it is.
Yeah.
Oh, everything's in down.
Oh.
Yeah, you can back up.
Yeah.
Just like another question.
Pretty much, we always just leave it on. I don't know why it's ever turned off, to be honest. You turn it on, it gives you more information. I think it's a relic from back when the 82s weren't able to, they didn't have much processing power, so they wanted to conserve. Now it doesn't matter. Everybody cool then? I don't see anybody calling me over. Everybody got that number? Yep. Okay, cool. I like it if you know binomial CDF or binomial PDF. That's good for you. But you better be able to set the damn formula up right. What I hate is when the formula is set up incorrectly, but then the right answer shows up.
Is there a way you can tell if you just do like how many total combinations are possible from that many possible?
Yeah, you ready? Watch this, guys. So how long do you think this list would be?
Really long?
38, yeah, 38 people, and I want to choose 9 of them. So maybe it's the first 9, or maybe it's the last 9, maybe it's the middle 9, maybe it's the first 2, the middle 5, the last 2. Holy shit. So if I just do 38, choose 9 by itself, that's the part that tells me how long the list is. So if I do 38, choose 9. Yeah. This is related to the pizza topping thing I was saying. 163 million. That's how long that list would be. So thank God we're not going to do that.
Well, I mean, like, that's specifically looking for like those 9 combinations. But say you have like, you know, like 100 people, and you would just want all the possible combinations to kind of lined up. Is there like you just want like to have?
Oh, I see. Then that would be permutations.
Okay, permutations.
And you do 100 P 100. And that, I don't know if that's going to be,
I learned that from high school.
it might be overflow error. You'll have to see.
So when I have the subscript, should we plug in for the subscript?
Oh, 9.
Overflow.
All right, so let me show you
Overflow.
on the new calculator here. Let's see, because I think more you have the new one now. You still going, or are you taking a break? No, you're still going. Okay. So if I do 38,
Hey, those are the answers to the test.
choose 9, right? 38, choose 9. Now, if you're going to plug the whole formula in, you better hit the over arrow so you're not still down there. There you go, same answer, thank God. Now, I only wanted to show you how long the list would be by itself. But when you do these problems, you put the whole thing in. I want you to realize something. This piece is always going to be stupid small. This piece is almost always going to be stupid big. So together, they come out to normal. Sometimes this by itself is too big for the calculator. But if you put the whole damn thing in there, the way that it calculates actually brings it back down into a good level. I don't know if that makes sense. So just put the whole damn thing in. I like it. Everybody decent with that? So let me give you this handout then. So this is section 4.3. So is it on the quiz form? Okay. Method to my madness. Definitely. It's definitely going to be on the test.
Oh, surgery.
I tried to go as nice possible, but it's just like a regular. Well, no, it's free.
If you want.
You're rolling for 3 years.
Fluidity.
What, bro?
Fluidity.
You wanna just know how many possible
Numbers, 24.
I can use that.
Then you got 3 separate things happening.
We got to do this presentation, if you said the set size, for all possible combinations, that'd be 6
So, don't worry about that right now. Worry about the handout.